Hi guys, so today we are going to start on the new section, which is going to be law of sines, and the following section is going to be law of cosines. So today I'm just going to kind of show you where this formula comes from, because I like to always give you guys a little bit of background knowledge. So we have our triangle and ABC, and the angles are going to be measured in capital letters. They're noted in capital letters, and then the side lengths are in lowercase, just so that we kind of keep that consistent. So first thing, to kind of show you guys a little bit of where this comes from, the height is the right angle. And if you look at that, we've got two right triangles. Here's one of them. And the second one is that one. Okay, so just to kind of show you guys the two triangles that I'm going to be talking about. So I'm going to just erase that, I think. Nope. So we'll leave that. And I'm going to just change colors. All right, so first thing we're going to talk about is angle A. So if I do sine of angle A, it equals opposite over hypotenuse, so H over C, okay? And then I can look at this green triangle, and I could do angle C. So sine of C is equal to, and then it's opposite over hypotenuse, so in this case, H over A. All right, so then once I have this, I've got two equations. What I can kind of do is just multiply by C for the first equation. So this is going to become C sine A is equal to H, running out of room there, H. And then this one is going to equal A sine of C is equal to H. And then from substitution, you could set them equal to each other. So C sine of A is equal to A sine of C, because they're both equal to, if you notice, H right up there. Okay, so you can set them equal to each other. And then we could do a little bit of razzle-dazzle. You can divide by sine of C, divide by sine of A, and then you get something that looks like A over sine of A equals C over sine of C. Okay, so that is how this equation kind of comes about. And we could also incorporate the B over sine of B in there. And that's kind of where it comes from, is this process. All right, so kind of using this as our equation, we're going to use the fact that A over sine of A equals B over sine of B equals C over sine of C. All right, so we can use this to solve triangles whenever we're given a matching set. So for example 1, I'm going to change this color. We're going to solve for all of the missing sides and angles. So in the triangle, I have angle A, angle B, angle C, and then I also have side A, side B, and side C. All right, so the things that I'm given are B is 29 degrees, angle B. Side B is 28 feet. Angle C is 102 degrees. All right, and then the other ones are all unknown. Now, the first thing that I could easily find is angle A. So I can do 180 minus 29 minus 102, because the three angles of a triangle should add up to 180. So A is going to be 49 degrees. All right. So that's the first one. It's pretty easy, straightforward to find. And now on your calculator, before we go any further, what I want you guys to do is take your calculator and change the mode, or check to confirm that the mode is in degree mode. All right, because before we were switching from radian to degree mode and degree mode to radian mode. So this one, it's going to be all in degrees because we're solving these triangles and they're in degrees. All right, so now the way that we know we can use the law of sines is if we have a matching pair. So my matching pair are the b's. So I'm going to start out with that. So I'm going to do side B over sine of B, which is 29 degrees, equals, okay, and then I'm going to do A first, so A over sine of 49 degrees. All right, so then I'm going to cross multiply. Keep this notation in your calculator. So we're going to do 28 times sine of 49. Okay, so I'm going to keep that cross multiplying. We get 21.13 equals A times sine of 29. And then we solve by dividing both sides by sine of 29. So I'm going to divide by sine of 29. And I get, and this is going to be, with all of these are going to round to the nearest tenth. So it's going to be 43.6. Okay. So let's see if I can make that connect. There we go. 43.6 feet. All right, now the last one we want to do is find C. So we're going to stick with our original pair, 28 over sine of B, which is 29, equals C over sine of C, which is 102. Okay, so we're going to cross multiply again. So we're going to do 28 sine of 102, and that equals 27.39 equals C sine of 29. So we're going to divide by sine of 29, and we get C is equal to, and now we're going to do this rounded to the nearest tenth, so 56.5. All right, and so that's kind of how we would apply the law of sines. All right, so continuing on, we've got example 2. So now this is a word problem, but it's still the law of sines, okay? So we've got a pole is tilting toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So we're actually looking for that side length A. All right, so right now I have angle A, B, and C. And then I have side A. That's the main one that we're trying to find, B and C. Okay, so angle A is 43 degrees. Angle B is 90 degrees from that little box right there, and then 8 degrees that way, so it's 98 degrees. And then I've got side length C is 22 feet. All right, so I can easily find angle C because it's a triangle, so I know they should add up to 180. So we're going to go ahead and subtract 180 minus 98 minus 43 to get angle C is 39 degrees. Okay, now we have our pair that we're going to use for the law of sines. So my pair is the C, and I want to solve for A, that's the side, so I'm not even going to worry about B. So I'm looking for A, so I'm going to do 22 over sine of C, which is 39 degrees, equals A over sine of 43 degrees. So I'm going to cross multiply. So we got 22 sine of 43. So we've got 15 equals A sine of 39 degrees. And then I'm going to divide by sine of 39. So I get A is 23.8 feet. And remember, if we're answering this, we want to also make sure that I do my units. So this is what the question was asking for. So I don't actually have to solve for B in this case. All right. So last one of these types. We've got another word problem. So we've got a course for a boat race. Starts at point A, proceeds down. Then we go this way. Oh, you hear Riley barking, going back up that way. So that is the length of the boat race. Okay, so we want to find what the total distance of the race course is. So we want to know all side lengths. All right, so we've got angle A is 52 degrees. B, we don't know. C, we don't know. Side length, all right, so it's A, this is C, and then this is B because they're opposite the angle. So A, B, C. So B is 8 kilometers. All right, so I am missing one key fact because for the other ones, I was always given 3 information pieces. So there must be something that I can figure out from this. So the thing that I could figure out from this is, if you notice, B and D and A and C are parallel lines, okay? So now if this right here is 40 degrees, that means this right there is going to be 40 degrees. So angle C is 40 degrees. All right. So now we've got angle A and angle C. So I can find what angle B is by doing 180 minus 52 minus 40. And we get B is 88 degrees. All right. So now we have our pair. We have B. So we're going to start out with that. And we're going to do 8 over sine of 88 equals, and I need to find all of the side lengths to find out what the distance of the course is. So we're going to do A over sine of 52 degrees. So now we're going to cross multiply. 8 sine of 52 is 6.30 equals A sine of 88. And then I divide by sine of 88, keeping that value in my calculator, hit the divided by sine of 88, and I get 6.3. Okay, so now I do my second one, which is the C one. So I do 8 over sine of 88 equals C over sine of C, which is 40. And we cross multiply, so we're going to do 8 sine of 40. Divide, so that is 5.14 equals C sine of 88. Then we divide by sine of 88. And I get, I got an error on my calculator because I typed the division sign twice. There we go. So for C, I get 5.1. Okay, and we're rounding to the nearest tenth. So now I want to know what's the total distance of the race course, and that was the whole entire triangle around. So for the race course, it goes, starts at A, goes boop, doop, doop, and back up at A. So we're going to add all 3 side lengths, 6.3 plus 8 plus 5.1, And we get my race course is 19.4 kilometers. That's my final answer. All right, so I'm going to have you guys take a minute right now and try the your turn applying those law of sines.